Hello and welcome to our webinar. I am Matt Griffin, Director of Community Development for Ultimaker. For this session, we will introduce you to a topic that has been taking the 3D printing world by storm, metal fused filament fabrication technology, metal FFF. And we will be joined by two experts today. First, Tobias Rödlmeier, Business Development Manager for the BASF 3D Printing Solutions team. He works on Ultrafuse metal extrusion products. And Andrea Gasperini from Ultimaker, who has a background in material science and works within Ultimaker's material market development team to help us leverage the strength of our material partnerships with our top customers. We created this session to get your questions answered about metal FFF and share insights into the collaboration between BASF 3D Printing Solutions and Ultimaker. We will show you how easy it is for you yourself to make stainless steel parts using BASF's Ultrafuse 316L filament and our best-in-class FFF printers, an option made possible by our commitment to keeping our material platform open, making it possible to extend printing capabilities at little to no extra investment. This webinar is created to serve intermediate and advanced users, but it also is an excellent introduction for new users who haven't yet encountered all the possibilities with high-performance materials on our printing platforms. But first, a little housekeeping. Our team will be in chat answering questions all session long. Therefore, please don't hesitate to ask your questions. Ask many and throughout the entire session. Even if we don't get to every question within the session, we will make every effort to send you a follow-up after the webinar is concluded. And finally, we are going to send you a link to the recorded video via email after this session to make sure you didn't miss anything. The agenda for this session is as follows. First, we're going to set the scope for the webinar by identifying a few common questions right off the bat that our customers have asked us, establishing the context for our metal FFF technology discussion that follows. Next, we will draw on our experts to go step by step through the process of using Ultrafuse 316L stainless steel filament, and we will then identify how this technology is applied in the field. Tobias will share a case study as an in-depth example of the process. We will discuss recent announcements about what's coming next to metal FFF technology. And finally, we will share some opportunities to learn more before we send you on your way. So let's now take a moment to set the scope for the session by identifying a few top questions that customers have been asking us about metal FFF. First of all, is it a real metal part? What is involved in post-processing? How long till I get my metal part? And finally, why 316L as opposed to other metals? Let's now introduce our experts who will help us address these questions and more. Let's start with Andrea Gasperini. As I mentioned before, Andrea has a background in material science himself, though his focus at Ultimaker is on material market development. So Andrea, welcome to our show.
Matt, thanks for having me here. I would like to take a few minutes now just to also share with you what we have developed and what we have discovered during this last year, working really closely with customer and BASF team. What we've noticed is that the production of metal parts historically has always been very operational and capital intensive. And then always been dedicated to really high-end production of parts for the aerospace and medical industry. And it was always seen as a too expensive process technology to produce all the thousands of specialized tools or small components that are actually used on a daily basis. With the solution that we are providing here today with BASF and Ultimaker, actually we provided the possibility to customer to produce in a very reliable way and very affordable way all the little components that actually they are using on their concrete floor. And we are doing that by keeping or outsource all the very extensive and expensive machines that are necessary for the production of the final metal part, and we are just allowing to internalize knowledge and services.
That's great. Thank you for that introduction, Andrea. And now I'd like to introduce Tobias Rödlmeier from BASF. BASF 3D Printing Solutions has been a material alliance partner from the beginning, and we have a number of their Ultrafuse polymer materials in the Ultimaker marketplace in addition to the Ultrafuse 316L. Welcome, Tobias.
Hello, Matt, and thank you for the invitation. I'm working for BASF 3D Printing Solutions, which is a company which was founded in 2017, and its people are only dedicated for additive manufacturing. So this is our only purpose, is to make BASF materials and non-BASF materials available for the 3D printing market. I joined that company in 2018, and since 2019, I'm working specially on the Ultrafuse 316L, or in general, on our metal filaments.
So now, with the help of our two experts today, we will be exploring in detail the process of metal fuse filament fabrication. Let's start with Tobias, who can share the history at BASF for the technology that led to making this possible. So, Tobias, considering my customer questions at the top of this show, what is this process and how does it indeed allow owners of premium fuse filament fabrication hardware, such as an Ultimaker S5, how does it permit these owners to actually make metal parts?
So first of all, I think we need to introduce metal injection molding, because our filament is based on that technology. So metal injection molding is a powder which is compound with a sort of material and additive, so polymers, which make the actual iron powder flowable under injection molding conditions. So this is the fundamental. And BASF is in that sense, since 1935, in industrial scale production of carbonyl iron powders, the so-called SIP powders. They were also the technology which was used for the magnetic tape cassettes, which are very famous because this is one of the products BASF had in the market, in the consumer market, where its logo actually was on the product. And this SIP powder is highly pure iron with a very good spherical shape in a micro scale. So this is the fundament, the raw material for our metal injection molding feedstock. With injection molding, you have the 3D shaping process via molding. With our technology, we use extrusion based on filaments. So you always end up with the green part. Subsequent, you need to get rid of the former helpers for extrusion. So you need to get rid of the polymers, binders, additives, which is called debinding step. But while removing all these binders, you have a little bit of binder left, it's so-called backbone, to keep the shape. And the subsequent sintering process, you have a thermal debinding process where this backbone is evaporated, and you have the sintering process started where the solidification starts. That means you end up with a metal powder densified. So we're talking about up to 99 or even higher density compared to bulk 316L.
And then this final part, going back to customers, to answer the question from the beginning of the show, it is indeed a real metal part, right? It's 316L?
It's 316L. Metal injection molding is in industry since 30 years. BASF, with its trademark cutter mold, is active in that industry since the beginning. And customers receive and get 316L parts. They have it in their daily business, and they don't even know that cutter mold or metal injection molding is also joining their life within their consumer products, for example.
That's excellent. Now let's include Andrea in this discussion. So Andrea, you have been working with top Ultimaker customers who have been leveraging this technology. What is their experience of BASF Ultrafuse 316L?
Yeah, sure, Matt. I can definitely tell you that the filament is very easy to handle. It doesn't require any fix or permanent modification of the hardware actually to really perform the primary function that a filament might have. So talking about loading and unloading, we're talking about retraction, extrusion of course, and as well deposition on the plate. So it results as a material that it's safe. So there's no powder laying around, there's no hazardous gas that have been released in large amount, there's no solvent in the chamber, of course, and as well, it results very easy to use, like all the plug and play experience that all the materials that are used on Ultimaker have. And as well, it's pretty affordable. So if we remember before, we were discussing about a really low total cost of investment for being able to produce and process Ultrafuse 360L. So in a nutshell, I also wanted to tell you that actually some accessory might be really useful actually to really be set for success. And apart from the printer and the air manager, what is definitely necessary is a CC core 0.6 millimeter that is necessary for processing abrasive material. Another necessary item is the Magic glue, definitely set for metal printing. Other components are the poly box that is really useful to handle and store the 3 kilo spool of Ultrafuse 360L, and as well as last as item a box of cleaning filament, really to keep your nozzle clean and not to have any deposit after printing. I want also to tell you that working really closely with customers, what we've seen is that initially, at least the early users, had a little bit of uncertainties, and they were a little bit skeptical on some design rules on what is happening during the debinding and sintering process to my part. So actually, if it's there are some problems sometimes that can be really easy to be solved with really simple items like the Magic glue, for example, a little bit of warpage. But when you want really to build complex part, then it's a bit of a different game. And actually, what we have seen is that you really need to set some specific guidelines and rules to really successful. Instead, if you really want to print a complex part, that you can, of course, with Ultrafuse 360L and Ultimaker, you need some specific tweaks. Let me explain you what it is. So even though the green part actually results as a perfect part to the eyes, it might have some inconsistencies or some a little bit defect that are going to be magnified during the debinding and sintering process. For this reason, actually, with the support of the BASF team, we were able to find the root cause and really to identify that this effect is not a casualty of the batch-to-batch variation during the binding and sintering process, but rather a design rule that needs to be respected.
Thanks, Andrea. That's a really clear story of the challenges that you and the Ultimaker customers were facing. How did you, the Ultimaker customers, and BASF work together to solve this?
Yeah, exactly, Matt. So what we did while we were working with customer and the BASF team, basically we discover and we really promote the fact that if you are setting the right settings, you are following the right guidelines, and you are using the right profile for Ultrafuse 360L, basically you will never have any problem, any negative surprise during the debinding and sintering of your part. Therefore, with the team during this year, we developed a series of information sets that are available for everybody to be used when they're using the Ultrafuse 360L. And the first one is basically the part features. So which are the shapes, the sizes, the requirements for that specific application that would really need 360L. On the other side, we develop a series of guidelines, a booklet, where there are all the design rules that needs to be respected, and as well a pretty solid print profile dedicated, where actually all these design rules are already incorporated. And on the side, BASF actually made a dedicated software that is used to mimic and simulate the shrinkage that can be a lot anisotropic there during the debinding and sintering in order to really get the right parts at the end of the process.
Thank you very much for that explanation, Andrea. And thank you, Tobias and Andrea, for going through the technical back end of this process. So, Andrea, before this session, we had discussed a few of the trends and usage that you were seeing in business from your perspective. So, based on your experience, what are the key business cases in metal FFF today?
Yes, Matt. So the focus of the solution that we're talking about today actually will always continue to be around the possibility for customers to produce small and complex parts that are part of large assemblies with thousands or hundreds of parts in metal, and as well all the tooling around the production of parts, and they are in your concrete floor. And also in terms of economics, so these are all parts that will be unnecessarily too expensive to be produced by other manufacturing technique, and they will actually they are unaffordable as well if we talk about all those big numbers. As you can see from the slide, here are a couple of examples of use cases that we have developed during our project, and we are trying really to aim for two specific categories. So the first one is all the little components which are auxiliary. They don't have a primary function, but they're all part and important part of large assemblies. And on the other side, tooling that maybe needs to be used in very harsh environment where plastic cannot actually be used as a viable solution. The major benefit that the customer actually have using our solution is the faster development process of specific components, reduction of the cost there, actually also being able to incorporate in their facility a technology that is complementary to the CNC way of working and the benefits of that technology, and the possibility to produce lightweight metal parts thanks to the fact that you can get a infill inside. So it doesn't have necessarily to be full metal part when it's not needed. In referring to application category and which are the companies that can benefit of this solution, actually it's really broad. So all the companies that are working on little components, on mechanical workshops, on development of engines, of big infrastructures, of maintenance of pipelines, for example. And these are only a couple of our customer segments that we are working at the moment.
Thank you very much, Andrea. It's really helpful seeing the trends and usage that the Ultimaker team has been observing. So now, in addition to the trends and usage that the Ultimaker team has been observing that Andrea shared, Tobias brought with him an in-depth case study that will help us to really illuminate this process. Tobias, what project did you bring today?
So I actually brought a part which was fresh from the beginning. So it was from September 2019. We released the material in July. So we were very excited on what the market is going to do with our material and how we are going to be challenged. The part we received was a clamping for a sheet metal laser beam welding production. The company was Höttge 3D, which is an engineering office and part production company in Germany. They have additive solutions based on SLM, and they also have their own conventional manufacturing tool shops. But the part we are talking about today was originally printed in ABS with FFF technology. But the harsh environment, where it was used, because it was very hot, and by the welding you also got metal splattering around. The part did not hold much cycles, so they were thinking on making a metal part for this fixture. But doing it conventionally or internally or even with SLM was definitely too expensive. So they tested us with our capabilities and our technology. So the first thing we did, we received the design, and the design was already very suitable for FFF. But in general, it was still driven by a lot of conventional technology and design thinking. So we stripped down everything which is basically required for the actual application. So we identified the minimal viable design, which is required actually for the application. From this design, we made the first prototype. And what was very critical for the company was that we achieved the tolerances. As one step, it was very important to identify which are the functional areas and also where do we need to look for specific areas, which are, for example, functional areas or functional surfaces. From that point on, we knew how the design should look like and also what a printing strategy need to look like. We incorporated a little bit adjustments on the design, we printed it, and the customer was very satisfied with the solution. It's now in operation and is used as spare part for the ABS part in their sheet metal production.
Thank you very much for bringing in that case study, Tobias. So now for our final section, we will discuss some of the recent and future developments for metal FFF technology. Tobias, just recently, you and your team at BASF 3D Printing Solutions made an important announcement about metal FFF, did you not?
Yes, we did, Matt. So finally, we released our 17.4pH material to the market. We already showed it several times on fairs, for example, Deform Next. But now in this December, it's time to officially release the material to the market. With 17.4pH, we have a material with higher stiffness and better mechanical properties, enabling more applications, especially with mechanical loadings. And its corrosion resistance makes it nearly ideal for the majority of applications.
And so what does this represent for BASF metal fused filament fabrication projects? Will you continue to expand the range of materials?
This year, we tested over 10 materials out of the cutter mold portfolio, which were filamentized and successfully printed, debound, and sintered. So from next year on, we want to broaden our material portfolio. And also, of course, we want to enable the applications and the projects of our customers. One of the materials which is highly requested is a support solution, which is also within our R&D pipeline, but also materials like titanium or low alloys were successfully printed, debound, and sintered.
Oh, that's great. And also when we were discussing some of the future trends for how you will provide resources for customers going forward, do you want to tell a little bit of the story of developing those profiles?
So the profile we have right now was our initial profile. We developed new profiles which will be released for the market for 316L, but also, of course, for 17.4pH. Our profiles are usually based on the expertise of our individual team members. So usually such a profile is based on the experience of applications and also R&D, which will be united and transformed in the profiles we have in the marketplace.
Thank you very much, Tobias. That's really helpful. And Andrea, what are you seeing as the future trends for how Ultimaker customers will make use of metal fused filament fabrication?
Matt, what we see at the moment is that there are more and more requests of interest from a customer directly to us, the BASF team, or even our reseller and sales partner to know more about the capabilities of the material. What we do is that actually we see an increase in also in the complexity of the parts and the potential that part needs to fulfill. So for this reason, we actually engage and we bring in the knowledge from the OEM, so Ultimaker and BASF, really to select and really to guide the customer towards the real and strict use of the guidelines to be successful. So for this reason, we set up a team from BASF and Ultimaker with the collaboration of our reseller and sales partner, actually to really bring all the expertise on the field for our customers.
So that's all we have time for today's webinar. And we have one special announcement, though. We are very excited about this technology at Ultimaker. And there is a workshop coming up that we want to draw your attention to. Andrea, do you want to share details about this workshop?
Yeah, sure, Matt. Let me give you a quick update on that. So we really would like to invite all the attendees of the webinar to contact us for 1 hour of free workshop where me and Tobias, we're going to deep dive into the fundamentals of the technology, and together in that hour already try to find a good match between your needs and the potential of the technology. We're going to tell you a bit more about the guidelines to identify application, and also try to already have 1 or 2 applications that we can start working on together.
We hope that this will be extremely valuable to you and your businesses. So thank you very much for your interest in this technology, and we hope you will attend that workshop. So thanks again to this session's experts, Tobias from BASF and Andrea from Ultimaker. Thank you for joining us today and sharing more details about metal FFF.
Matt, thanks for having me here today. And Tobias, thanks again for joining us webinar today.
Yeah, Matt, thank you for hosting this really beautiful webinar. And thank you, Andrea, for your support and your presentation.
As a reminder of what we covered today, first we set the scope for the webinar by identifying a couple of your top questions. We went through a process of using Ultrafuse 316L from design to fully metal part, including some details about the technology behind metal FFF. We discussed how this technology is applied in the field. Tobias brought in a case study that was an in-depth illumination of the process. And Tobias and Andrea discussed recent announcements and next steps for the technology. We want to thank all of you attendees for coming and asking your questions and spending time with us here on the Ultimaker webinar. And we hope that you will check out some of the links that we include in the email that we send out, including links to sign up for the workshop that Andrea just mentioned. In addition, we have some resources for you to help you find anything you need at Ultimaker, including finding a reseller local to you, and other documents and resources, including a white paper that discusses the metal 3D printing technologies with a comparison to show how 316L stacks up. I also want to strongly encourage you to check out our podcast, Talking Additive, which has an episode featuring Tobias and his colleague Roger going into depth about metal FFF and all of the offerings from BASF. So you will also, in the email that you receive, have a link to see the entire video. So thank you again for your time, and we look forward to seeing you at a future webinar.